Good morning students. In the previous video I think here video got blurred, so I am making this part of the video once again. So I want to tell you, see, from one side nitrogen is entering, right, and from one side hydrogen is going inside, right. Nitrogen is taken in one volume, hydrogen in 3 volumes. They will meet, these two gases will meet in a compressor, and from compressor they will directly go to a chamber where 250 atmospheric pressure will be there, as it is written here. You can relate this video with the previous video, right? When this both the gases will go here after compressing, right, clear, and finally divided powder of iron will be there, and very small amount of molybdenum or Al2O3 can be used in case of promoter, right. Then both the gases will be taken to a cooling chamber. Almost gases started reacting with each other, and they will be taken to a cooling chamber so that the gas formed will be liquefied easily. But I told you that 15% of the gases only react to form ammonia. Other gases will not be forming, so the part which do not change into gas will be taken back through this pipe, and you can call it a recirculating pipe, and again brought into a catalytic chamber, where in reality they are getting converted into ammonia gas, right. So this process will be repeated again and again, right, and by this the yield of liquid ammonia we can increase. And as you already know that the nitrogen here present will be taken from the uh, fractional distillation of air, and hydrogen present here will be taken from the Bosch process, which you have done in the 9th class, right. Okay, now we are moving to the next part. This next part is to be like this, that favorable conditions, right. What are the favorable conditions for Haber's process? Favorable conditions are temperature should be 452 to 500, 250 atmospheric pressure, finely divided iron, and molybdenum and Al2O3 is promoters, right. Now I will not be going deeply in this diagram because I have already explained in the previous video, right. And the recovery of ammonia, right. And this recovery of ammonia is to be like this, that liquefaction of ammonia is very easy as compared to liquefaction of nitrogen and hydrogen, but we are not going to liquefy it, because ammonia is a reversible reaction. Because when we are preparing it with Haber's process, it is a reality is that it is a reversible process, and due to large amount of heat involved in the reaction got reversed. So however, formation of ammonia is quite easy, right, but it is a great difficulty. Due to that temperature we required recirculating pipes over there. And here also it is written that only gases contain nearly 15% will be the ammonia. The mixture is passed through the cooling pipes and condenser. And then I am moving towards this, and they are saying pressure can be from 200 to 900, but in reality they are taking only 250 atmospheric pressure, right. Catalyst and promoter is there. Catalyst, you know that it is used to speed up the reaction, but the promoter is there to increase the efficiency of the catalyst, so that catalyst can work more efficiently, more powerfully, right. And one more thing, the gases which is to be taken in the Haber process, like 1 volume of nitrogen and 3 volume of hydrogen, these both the gases should be pure. If they are not pure, then there is a problem. What? They can impure or they can poisons the catalyst, and mainly the impurities present in these two gases are H2S gas, as you already know, we have done last year, related to hydrogen. Carbon monoxide, it can be. Traces of sulfur, it can be, right. Carbon dioxide can also be there. Moisture can also be there. However, these 2 3 are not written here, but I told you that these impurities need to be removed, okay, which generally poisons the catalyst. Now we are moving towards the physical properties of ammonia. Ammonia is generally colorless, but its odor is very, means strong odor, and it can cause a choking smell. However, Here it is written non-poisonous, but if you inhale in a large quantity, right, for 5 to 10 seconds, right, you will be having severe pain in your chest. Your eyes will start giving tears, right? And because it is, reality is that it is a powerful heart stimulant, due to which there can be cause of death also. Its taste is bitter because as it is basic in nature, right, uh, whereas acids having sour taste, right. Let's move to the next topic. And next topic is density. It is lighter than air, right? And nature is alkaline, right. Liquefaction, it liquefied easily, I told you earlier also, at 10 degree and only 6 atmospheric pressure. But in the reaction of Haber's process, we require many other things I already discussed. Boiling point, minus 33 degrees Celsius, freezing point minus 77. Solubility is very high. Its solubility is much more than HCl gas, where there is soluble only 452 volumes in 1 volume of water. Here the solubility increases up to 702 volumes at almost room temperature, at 1 atmospheric pressure. Now we are going to discuss the fountain experiment. Directly I am going to explain the fountain experiment. Here inverted round bottom flask is fixed on this capillary tube, right, clear, and a dropper is there which contains a small amount of water in it, and red litmus solution is taken. Here with the stand, this apparatus is to be hold, right. Okay, this container already contain ammonia gas, right. This container contain ammonia gas, right. Okay, so when here difference in the pressure, right, both areas having different pressure, low pressure, high pressure area, right. And the moment we will press this dropper, right, there will be some water droplets which is already present in it. Water droplets come here, right, and due to the capillary action, the movement of red litmus solution will be there. Means liquid start gushing through here and it will move here. But because it is a basic gas, so it will start converting this red litmus solution to a blue litmus solution, right. Due to this, what happened, there is a formation of a blue fountain. Now many of the students do this kind of a mistake, that they think that if it is changing into a blue fountain, then we will write in the exam that it is very it is a basic gas. No, but here we are discussing about high solubility of the gas in water, right, clear. So as you know, since outside pressure is higher, right, the red litmus solution rushes up through the jet tube and emerges as a blue fountain. Understood? So it is a easy topic. Now we are moving towards the chemical properties of ammonia. Thermal dissociation. On thermal dissociation, we have discussed this reaction in the previous video also, that on thermal dissociation, gases will be converting back into nitrogen and hydrogen. We have already discussed about this lone pair also, that this ammonia later on will be helping H positive by donating both of its electron to H positive and making one coordinate bond. However, these three bonds here present are acting as a covalent bond, right. Okay, and aqueous solution of ammonia is NH4OH. If we add water in ammonia gas, means when we make ammonia gas soluble in water, then this is called as NH4OH, right, which is considered to be as a weak base also. It dissociate into NH4 positive and OH negative as it is written here. Okay, so what is the action on different type of indicators of this gas? Red litmus will be converted into blue. Methyl orange, if it is in methyl orange, as it is in orange color, it will change to yellow, right, clear. And phenolphthalein is colorless, changing to pink. Okay, so this is all about in this video. Thank you.